Here is the Mathcad for a welded portal knee, and this is common in house frames. So we're doing it again in accordance with our own code NZS3404. We've taken the values of the forces from a separate analysis. And the design philosophy is that the applied moment is resisted by tension in the butt welds connecting the tension flanges, and the applied shear is resisted by the fillet welds in the connector of the web stiffener. So what do we need to check? Well, tension in the butt welds due to applied bending moment, shear in the fillet welds due to applied shear, and shear yield in the web. So here's our connection geometry. Our beam and our rafter is 200 AFC. Our material properties, as before, we're using grade 300. We have a 6mm fillet weld. So we can derive, as before, the nominal capacity of the fillet weld multiplied by the length of the weld, and gives you a design capacity when you apply the strength reduction factor of 220 kilonewtons. We have a butt weld, which is the same thickness as the plate, and so it's 12 millimeters. We're assuming that the butt weld strength is the same strength as the material you're using for the main sections. So your nominal capacity of a butt weld in the flange is 387, and the design capacity when you apply your strength reduction factor is down to 232. So let's compare it with the loads we've extracted from another piece of analysis software. So we're applying axial load, shear and moment to this connection, but we're also pulling out from previous calcs the nominal bending moment capacity or the buckling moment capacity of that beam. Why do we do that? Because we need to check the minimum connection forces. So for frames not subject to seismic loads, we look at clause 9.1.4. That gives us the minimum connection forces that you need to design your connection for. If it is subject to seismic loads, you need to look at clause 12, and that will give you the minimum connection forces for that. The reason behind this is you have a building frame and you want it to be robust, and so it's about avoiding a disproportionate collapse and progressive collapse. So you want to basically tie your building together, your frame members of your building together with at least the minimum forces. So your applied moment, your applied shear is going to be either the minimum of the applied loads or the minimum loads that you've put in, calculated from clause 9. So we begin with a check on the butt weld resisting bending. And so the tension forces in the flanges are simply the applied moment divided by the lever arm. So this is the depth and the distance between the centroid of the flanges in this case. Look at the fillet weld resisting the shear. So we know what our applied shear load is and our shear capacity of that. Check on the web shear and we compare that to the capacity. And in each case, we're below the capacity. Okay.